Now let's see how to set up the miniconda environment and also install all the required packages for this A to C PPO and DQN algorithms, and how to train the car in simulated environment. We have to be on the same network to connect over the VNC. Right now, like you can see, I'm connected to the Nolla, and as per the installation steps, I gave the information to connect to the Nolla network and with the password. So my laptop is connected to the same network as the Raspberry Pi 5, so I can use VNC client to connect to the Raspberry Pi 5. So right now, just a second. So right now, I have connected Raspberry Pi 5 and did all the wiring with that. So yeah, and all the pins are in BCM mode right now. I'll show you later in the code. And then yeah, so all the sensors are the same as the pins in the settings. Right now everything is connected, and there is the power bank under the batteries for the car. I'll have to turn it on for the motors to spin. So yeah, I'll show you in a second. Let's try to connect to that. This was the host name I specified, so I'll do that. Continue. Pi 5 was the username, Pi 5 was the password, remember it. Okay, so now I'm connected. You can select from the properties the quality to be low, so that the performance was on the Raspberry Pi 5 is not that impacted. I think this is enough for now. So quality will be a little low, but if you like to use it normally, then it will be a little faster, like right now. But for this video I'll just set it to high. Okay, and then so for this, first I will have to transfer all these files to the Raspberry Pi. So I'll just create a folder in the desktop, future IoT, and I'll just copy it over here. I'll open a terminal here and then transfer the files over the SSH. So I have the terminal, and then SCP here, move it to there. Yes, come on. Yes. Okay, so password Pi 5. Okay, let's see. City desktop. So this is here under the feature ID. Okay, so all the files are transferred to the destination. So let's go to feature ID and then here. Okay, so let's open the project on VS Code and let's see. So I'll follow these steps. First I will install miniconda and then install a few required packages that are required. Yeah, or I can install this right now. But before that you have to do sudo apt update, because this is the new setup. So do that, and then sudo apt upgrade. Yeah, let's do that. Now I have updated it, so sudo apt update, and then upgrade. Everything is up to date, and I installed all these packages. So these are required for Python, and yeah, these are also installed. Now I will create the miniconda environment. You can follow this guide, miniconda installation guide, and there is this quick install instructions. I will use that, and you can do uname a. You can see the ARM architecture 64, so I'll go with the ARM 64 here, and then activate the environment, and then initialize it for all the shell profile. So let's do that now. Copy this, and then do this. Now miniconda is installed, and it activated the base environment. Exit, relaunch it, and then increase the font a bit so that it's easier to read, and let's get this. So I'll initialize, create the Python environment. So if you go there, there's a Python version, and I will install the requirements with this. And depending on the Raspberry Pi, it either can support this LGPIO or RPI GPIO. So to confirm which one it is, you have to use, like, deactivate the environment, conda deactivate, and then you can use Python here, and not this, but like you can use pip freeze, and then grep GPIO. Then you can see RPI LGPIO. So then you get the clue, you have to use LGPIO in the requirements.txt. So over here, like, so right now I have installed this one for Raspberry Pi 5 and Pi 4. This one works on both Pi 4B and Pi 5. So yeah, but just a caution, you might have to, like, this might throw error, so you might have to, like, comment this out and then, like, install the GPIO depending on the one supported manually with pip install command, like this. So since this works on the Pi 5, it will work right now. So let's try to install that. Oh, but before installing it, I have to create the virtual environment. So let's do that. Conda 33. Let's do this. Yes, install everything. Let's go to desktop, and then cd future IoT, and then robot CLI. Okay, now I'm going to do, notice I have this P313, the one I created just now is activated, so you have to do that. So pip install requirements.txt. Now that all the requirements are installed, I can go there. So let's walk through this environment here. So like in this folder, all the trained models are here. So this 500 means I specified 500,000 time steps. So you can train it with this command in the simulated environment. You can train it on your laptop, PC, whatever, so that it would be faster to train, and then on the test on the GPIO. So I'll show you, like when you run with Python this like directory, it will invoke this script, and then here, like if you specify this train, then it will train the models, and then if you specify eval, then it will try to find these models DQ and PPO A to Z, and then you can like select which one to evaluate and evaluate that. So, and also like you have to choose the render mode. So this is mandatory to specify one, like two argument has to be specified. So either train or eval, and render mode, so it can be GK graphics, so TK graphics or TK intergraphics, and then GPIO. So this means GPIO is the robot car. Yeah, and then you can customize some of the settings here in the robot car and directory under settings. So you can change the, what is it called, models directory. So right now I have it set to the train models. Like from where you run the command, it will take that path and then create a folder there, train models, and also the logs will be there as well in here. And then yeah, next there is a tracks folder, tracks, so is here, and you can like create your custom track. So right now, like I created this one. This is closer to the classroom's track, so the difficulty is almost closer to that. I think like this is a little bit difficult than the one in the classroom, but this was the original one. It like the robots learn fast here, but sometimes fail to, and not sometimes, but most of the time fail to like follow the line. So that's why I created the other one, and you can like create another one and update it over here, edit over here. So like you have to give the same name as the file name inside the trucks folder. So, and you also like specify the trucks folder here, so it's here, and then you can like specify the initial like car position. So I would recommend to like put the car on the line so it launches faster, and then like you can pause the simulation, like it won't like move the car forward. So like in that case it will be easier to like test and put the car change the value, and like change the value over here, and then like make it false. So yeah, it'll be easier to like put the car on the truck by modifying the values. And then yeah, there are some other variables. So car base length, I would not recommend to like mess with this stuff, but like you can change the, of course you should change this one if you add another one. And then these are the GPIO pins, so it's easier to like change this and then experiment with the stuff. And this is the main part. So like to like create a different like model, you can specify different time steps, and then you can run it like in the training mode. It will like run all the algorithms, these, and then these are the keyword arguments to these models. So you can read the source code how it's working over here. this is the training, and then this is the evaluate models. So yeah, like try to like understand what's happening in the gymnasium environment over here, and then in the GPIO, and in this one. And this callback is to like uh, early end the training. If you press Q on the keyboard, or like close the training window. So yeah, so let's try to and like depending on the map and the length of the track, you have to change this one. Otherwise, if you finish early, then the car won't, like you won't have the time to have at least like one round in the truck. So yeah, and yes, I think that's it for the settings module, and you are on your own to like explore the whole project over here. Now let's try to run this on the Raspberry Pi. So let's get the command to evaluate. So first I'll try to evaluate one of the models. So RM is the short form for the render mode. So I'm specifying GPIO, but let's see what happens if I just run it like this. Okay, oh yeah, it don't work because I was in that directory. So I have to do this in the base directory where the file is, the folder is. So it should just like show me the messages. So this, and then this is optional. So if you do this -h flag, it should show you all of these messages. And then render mode, GPIO, and then what was the other thing? Yeah, I want to evaluate it. So eval, let's try that. So it's asking which A to C model I want to test. So I have like 500,000 time steps. I trained one of them, and then there are other ones. So I'll try the best one. So it's the 500,000. So just for observation, I will like make the camera bigger. I'll choose 0 and then start. I will have to turn on the switch of the motors. So as you can see, I'm blocking two of the sensors, like 1, 2, 2. These are reading right, so these are off the line, and then these only the left. So yeah, and then if I press Ctrl C, it will ask me to try the next one, DQN. So I can try this one. I'll try 0 maybe. Let's see. So these two are blocked. Right, the ones on the right are blocked, and then the ones on the left, and then only one, middle, right, left. So yeah, this, and let's try the one of the PPO. Let's try one. PPO is not that good. Yeah, it doesn't do anything. Yeah, you have to like try to fine tune this PPO. you can also change the hyperparameters. To change the hyperparameters, you have to like come in the main module and then create your own train models function. Maybe like try to manually do that. You can turn off the main function and then do whatever you want, like here, maybe also here, whatever you like. And then you can specify more like parameters here. I can show you the docs. So stable baseline 3 documentation. You can go to, let's go to A to C, and then where's the learn? You can see learning rate when you specify the model gamma. And these are the hyperparameters. Like you can choose. The parameters might vary depending on the model you're choosing. And then also in the learn, yeah, you can experiment with everything you want. And let's see. So let's try to train a model quickly. So I will just try to edit one of them. CD on, let's say, genie car, I think, robot car, and then settings. I will make everything like really small. I will disable the DQN and PPO. Only use C, A to C. I will use time step like 1000. This 100. This is just for an example. So let's save this. Just letting you know, 100 is not like is nothing. You have to at least try something about like 100,000 with A to C, and DQN I think maybe around like 180,000 will work. But for PPO I'm not sure. You have to try different trucks and other stuff, but PPO is really bad in my opinion. Okay, so let's try to train it over here, or at least like put 1000 maybe. And then let's close this editor. Okay, so now train, use the environment. For the training, always try to use the, I mean not try, but always use the TK graphics. So you can see when the sensor is on the line, it will show in green. So it's done, I think. Less. So tensor board logs are here. If I do 3, then you can see it created A to C1, and then A to C1 1000. So I was like to the key to keep these numbers really like small and readable, I divided the time steps by 1000, so that's why this is 1. So now let's try to test this one. Eval on the graphics. Let's see how it's doing. So this is A to C, and then this is 1000 steps. So, and it is 2. As you can see, this is not that good. So yeah, you have to train more, and you can like press Ctrl C. That's it.